What I'd like to do with you now is to take you through the 12 proofs and give you a few hints or show you a couple. These 12 are going to be what you actually will end up doing as a part of your homework. And so I'm going to give you some heads up and some help. Let me just start with the very first one and give you an example of how we would write this type of proof out. So here's our given, which we're going to write in a minute. But ultimately, what does it mean to be parallel? I think you're aware that parallel lines are going to give us all kinds of good angles. And you can kind of pick which angles to use, but I certainly see this alternate interior pair. There'd be another alternate interior pair if I wanted to use it. And actually, there'd be vertical angles. So in this particular question, you'd have pretty much choice of whatever angles you want to list. Let me write those down. So in my case, I chose to stick with the alternate interiors. So I mentioned that VTP, so that's this guy, is congruent to this guy by alternate interior. And then I mentioned that these guys are also congruent through alternate interiors. I could have done the vertical angle, but I just did so much of that over the last while. Why not try something new? So then my final statement would be the actual proof statement that they are indeed similar. And the reason would be just simply AA. Again, you could have done something slightly different there than me, but that's fine. Let me go to the next one. When I look at this one, I see immediately a little trick in the game here. And it has to do with this bottom corner down here. I want to mention to you that this is a common angle. Now, you and I did a lot of things with a common side, so it's still a reflexive property. It's still angle H is congruent to angle H by the reflexive property, but a common angle is definitely going to help you out there. In this question, they give you some information about a parallelogram. And if you remember the information we gave you, but if anybody gives you a word, you've got to use a definition to pull out of that word some information. So what we do know about a parallelogram is that the opposite sides are parallel. I think that's what we really want, because once you get that, then you can start naming alternate interiors and vertical angles and things like that. So the beginning of this proof would look like this. So as expected, the first thing I do is I write my given exactly the way I see it. Now ultimately, a word needs translation power. So what I'm going to then say is, what does that really mean? Oh, it means that those lines or segments are indeed parallel. And that is by the definition of parallelogram. Now you can begin to list angles and all kinds of other things to get this proof going. Let's keep looking for more hints. What I would say about this one, when you see parallel lines, immediately I start to see corresponding angles. I think that's going to be helpful to you. Oh yes, these are kind of weird. Let me do this guy with all these number values. Ultimately, if you see any numerical values, this is going to have something to do with proportional sides. So let me show you how to set that up. So as expected, I went through the process to list out the givens. Each of those lengths is provided. And then ultimately, I need to find a way to connect these guys together. And so I set up my proportion. 4 is to the 12, as 5 is to the 15, and they come out to be the same value. In other words, I have two proportional sides. So I physically showed that they're proportional. Now, there isn't another side, but you do see it. There's a vertical angle there, and so we would say angle KLN is congruent to angle HLY, because vertical angles are congruent. And your last line is now, we're definitely got a side angle side environment. And so we could now say triangle KLN is similar to triangle HLY by a side that's proportional, an angle, and then a side. So that kind of gives you tips on the first 6. Let me just do a quick perusal around here. What this is ultimately giving you is it's just giving you a ratio immediately between sides. So already, really, what you have is a side-side relationship. Can you find an angle that would fit kind of in between those would be what you would be doing there. Now let's take you through one more level of things. I want you to notice that this one wants us to prove something is proportional, and this one wants you to prove something's been cross-multiplied, which is kind of new. This one wants to prove something is parallel, which is kind of new. Now the idea is, let me just put this aside for just a minute and talk to you about the idea of those. If you can go through a proof, ding, 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 and name something as similar to something by, let's say, AA. Once you've done that, kind of like in the CP/CTC world, once we prove things to be congruent, we were able to talk about parts and pieces. The same thing is true here, you guys. Listen carefully to this idea. Once you state something is similar to something, after that, you can name angles that are congruent because you know that those are truths in a similar triangle, or you can begin to name proportions that would be congruent based off of that idea. If you can put those ratios together. So like when we were done here, we named congruent parts. Here you can name any angles you want, and you can make any ratios that you want. So what that means is when we see something like this, the idea is first you would prove them similar, and then right after you prove them similar, you could say, hey, this is congruent, and why? You would say, because the similar triangles, right? Because they are similar triangles. Same thing here. If you and I were able to prove that this little guy, this triangle, is similar to this triangle, which I think we could do, as soon as you name them to be similar, this would be a follow-up statement. You could say, well, that would mean these are proportional, and your reason would be that the triangles were similar to each other. We don't have like a CP/CTC thing, but we just name it to be like this. So let's do one. Let me do this big, bad, ugly one right here. It seems to be one of the bigger ones. Let's do this one from scratch. So let me get it set up. Let's make sure you know how I got this far. Here's my given, no problem. What's good about parallel lines is you get lots of angles. So I say BAH, that's this guy, is equal to DHA. It's this guy. These are alternate interior angles. In this case, I chose to list the vertical angles, AGB and HGC. There are my vertical angles. And now I had two angles, so I can make the statement that they are indeed similar by AA. As soon as something's similar, we can name sides that are proportional. We could name angles that are equal. By this thing here, I know that I better talk about sides being proportional. And I want to include the sides that they have here. So I notice they have a GA. So let's start with GA. And GA's partner in the other one would be to GH. And I also know that they talk about a G, what do they talk about? A GB in this one. And then that one corresponds to a GC. And this basically is that the triangles are similar, so we get proportional sides. Now, that's not an official statement, but basically the idea you're saying is that why do I know this ratio of GA is to GH as GB is to GC? Because the similar triangles give us proportional sides. Now, so far we've made a nice step past that. That's true. Now the last step is to get to the proof line, which is to just simply cross multiply. So if we cross multiplied these, we would get GA times GC, and we would get GB times GH. And that's just simply cross multiplication. So this is a lot like CP/CTC for us. And what basically we did is up to this point is just proving something to be similar. Once something is similar, we can then name something that we know based on similarity. And so we can say, hey, things will be proportional because our triangles were similar. And then we look at the proof line and we say, oh, the proof line wants us to multiply that out. So let's multiply that out, and that is just simply cross multiplication. Let's give one more quick little hint here. The more hints, the better off you are, for sure. Here I see 3 sides. Guess what you're going to do? You already saw me do one like this. So set up a nice ratio once you put that in, and see if you can prove this by side, side, side. I think it's not going to be hard. Let's talk about this one here. Obviously, they want us to talk about a proportion. So first you need to prove similarity. They gave you one set of angles here. And you got some options after that. Would you like to use the common angle here? Or would you like to name the other corresponding angle? Lots of angles in this diagram for AA. Once it's similar, you then can tell me about its sides being proportional. And same kind of deal here. I think that's plenty of clues. I think if you follow my lead on how to write some of these guys, you're going to be in good shape. Good luck, my friends.